Okay, although dangerous, I would square both sides to get rid of the radical. And so this one would become 2x squared minus 9 equals, let's see, 9y squared plus, let's see, 3 times 6, 18, 36y plus 36. The second equation, if you did the squaring of that, you get x4 minus 17 y squared equals x4 minus 10x squared plus 25. All right, so I'm noticing something immediately, that the x4 subtract from both sides, that just disappears, all right, which is good news. So the next thing I do is just, I guess I can get letters on one side, numbers on the other, see what happens. So over here, the first equation, you get 2x squared minus 9y squared is equal to 45. Whoops, we're at 36, didn't I? Minus 36 equals 45. Let me just check that. 2x squared minus 9y squared minus 36y. Whoops, forgot that guy. Yeah, 45. Let's do this, the other one. What do you get there? 10x squared minus 17y squared is equal to 25. Let me just check that. Good. Okay, so I got two letters in it. I want to get to one letter problem. And the way I'm going to accomplish that is to multiply the top equation by minus 5 and add them together. Well, what's minus 5 times that? Minus 10x squared. Let's see, plus 45y squared plus 180y. And 5 times 45 is minus 225 now. These two equations here are being added together now. Let me get rid of my distractions, old stuff. Don't worry, we have a key to look at to make sure we're going in the right direction. If you add this together, though, you're going to get 28y squared. Let me check that, make sure that's correct. Let's see, 23, yeah, 28 plus 180y equals minus 200. Things are becoming much easier now. Again, I'm going to race the past, so to speak. I'm moving forward into the future. Next thing I do is, it looks quadratic in y, so I'll write this down. 28y squared plus 180y plus 200 equals 0. The numbers are getting kind of big on me, so what I'm going to do is divide through by 4, and you get 7y squared plus 45y plus 50 equals 0. Again, I'm thinking about moving forward. And I'm hoping that is nice, and it looks really nice. It looks like 7y, and y is the only finger number choice. And then 50, I would say 5 and 10. Plus plus, does that work? Like a charm. You get 7y squared. You certainly get 35 and 10, which is 45, and you get 50. So I get two answers over here. Y equals minus 5, and y equals minus 10 sevenths. So I want to go back to the original and write that down. So I think y is minus 5 and y is minus 10 sevenths. I think this, right? How do I think that? I did this. I get those two numbers over there, minus 5 and minus 10 sevenths. I immediately notice a problem, though, and I'll tell you the problem I've noticed. If you plug that in here, that would give you minus 15 plus 6 with a negative number. Well, square roots are principal roots, so I can't use that. So this one here is going to be crossed off. That's gone. I'm not going to do that. I want to do the other one now. And I'm going to plug it in. First equation, because it looks the easiest to me. You get 2x squared minus 9 equals minus 30 over 7 plus 42 over 7, which is 12 over 7. I'm going to square both sides. That's 144 over 49. And let me get my eraser out now. I'm moving forward. Let me get rid of this. Feel pretty good about it. Let me get rid of the nonsense over here. I don't need this anymore. And I don't think I need this anymore either. And I'm looking at this and I'm moving forward, all right? So I'm using this to see if I can get an x. And it looks like I'll get 2x's for that. All right, let's see if we can do it. And so 2x squared equals 144 over 49 plus, well, I got to do this now. And let's see, 50 times 9 is 450. And then minus 9 is 441. Yeah, nasty looking numbers, but let's keep doing it. What do you got here? X squared, 2x squared, sorry. Let's see, 585 over 49. Let's keep going. X squared. Well, I'm going to do something crazy because I know I have to take the root of it. So it's going to be 2 times 7 times 7. Now I'm going to look at the 585, and I want to factor it. Certainly by a 5. This would be 1. 5. Don't be alarmed yet. This is 8. That's a 1. 5. 35. That's 7. Right? So you certainly get a 5. Now I'm looking at the 117. And that's divisible by 783. I'll put this down. So it's going to be 3, 9, 27, 9. So I'm seeing 3. And 39 is 3 times 13, right? All right, so I know it's a lot of work. To me, it's a lot of work too, including very prone to error. I want to make the bottom a perfect square though. So I can multiply top and bottom by 2. So what's x going to be equal to? Plus or minus? Well, the square root of the bottom is just 2 times 7, which is 14. And what do you get on top? You get 3, and then you're going to get 130. All right, I think I got an answer now. And I'll write it down for you. So we're going to get 3 root 130 over 14 minus 10 sevenths. That's what we used, right? Yep. And the other one's going to be minus 3 root 30 over 14 minus 10 sevenths. Let's get the red ink out, see how we did. Did I get this? And did I get this? I did. We also brought a picture for you. And I also discounted minus 5 is not making any sense. It doesn't make any sense. Let's look at the picture, though. And the picture, it's a tough picture. There's no doubt about it. We're getting 2 points of intersection. Now, someone says, the picture's really kind of like crazy. Look, I'm seeing a picture just like that. It's crazy looking. It's the graph of that system. And that's a tough system to graph, by the way. It's a really tough system to graph. All right? So we graphed it out. We found the 2 points of intersection. And that's about it. All right? Thank you.